So let's solve today's POTD, maximum number of operations to move ones to the end. So we are given a binary string S, it will have only zeros and one, and we can perform the following operation on the string any number of times. Okay, so in one operation I will choose an index I such that I plus 1 is less than s dot length. Okay, and the condition is that s of I needs to be 1 and at least there is 1 0 after that 1. So we can move the 1 to the right until it reaches the end of the string or another 1. Okay, so if we choose this index, we can choose this index because there is at least 1 0 after that. We will transfer it to this particular index and so it becomes 1 1 0. So we have to, and there is a limitation. We cannot just do this infinite number of times because after certain number of operation it is guaranteed that all ones will reach the end and I won't be able to do any more operations. So we need to return the maximum number of operation that you can perform. Okay, so if I start from back, then what will happen? I will do one operation in this index, it will go here, then another operation, it will go here, then another operation for this 3. Okay, so in that case it will not be maximum. So if I start from the beginning, then what is the case? For this index, if I apply it, it will come here. So now these 3 ones become a single group, and then I will apply again 3 operation on these 3 ones to make them reach these indices. So if we do it from starting, then it's better, and in this case I cannot do any operation because all ones are already at the rightmost position. So let's take one example. 0 or 1 0 1 1 or 1 0 0 1 1 0 0 1 1 0. So in this case, after first operation, as I already saw from the first test case, that doing it from back will not give me the most maximum answer. If I do it from start, then I will get answer which is maximum, because in that case I have to first send this one to its nearest one, and then the entire group needs to be moved to the next group of ones and so on. So it will consume more operations. So in first operation I will choose this index, so it will become 0 1 1 0 0 1 1 0 0 1 1 0 1. In the next operation I have to choose the 2 index in this group separately. So here plus 1 operation, and now if I do plus 2 operations I will get 1 1 1 1 plus 2 because I choose this, then I choose this, so they all will come here and they will become a new group. Then if I apply to these 4 ones individually, then I will again get now this becomes a new group. I applied how many operations? 4 operations. Then if I choose these 1 2 3 4 5 6 ones, then all these one will go to this particular end part. They will shift by one place. So plus 6. So what I can see from these observation is that I have to do the operation from front in order to maximize my answer, and I have to think the ones in terms of groups. So I will take a prefix count of ones, and when I am at the end one of the group, I will add the prefix count of ones. Like in this case, I added 2 because I was in this index. When I was here, okay, so let me do the dry run for the code that I'm thinking. When I'm at this index, my prefix count of 1 is 1, and I will add 1 to my answer. When I am at this index, I won't be able to do anything. When I am at this index, I know that this one has already become part of this, the 2th index, the second index one. So now I will add plus 2 because plus 2 operations will be required to send these two ones to the next 2 index, and they will become a new group. So till now answer is 3, that is 1 plus 2. Now the group size is 4. So when I am at this index, I know till now I have 4 ones, so I will add plus 4. Then I will reach this configuration, and then I will do plus 6, and I won't do this type of operation for the last group because in last group I won't be able to do any operation because they are already in the perfect position. So let's do the code. I'll take one I, and while I is less than j, and I will have an I is less than n, and I will keep one count for prefix ones and one for answer. So the answer should be 6 plus 4, 10, 12, 13 for this test case. If s of j is equals to 0, then simply I plus plus and continue. Otherwise, what I can do is while j is less than n and s of j is 1, 1's plus plus and j plus plus. Now, if I am not in the end group, so j needs to be less than n. If I am in the end ones group, then my j will be equivalent to n. So in that case, I won't add ones to my answer, and I will do I equals to j, and I will return answer. I think this much is so 13. Yeah, it's correct. So let's submit the code. Yeah, it's accepted. Thanks for watching.